All right, get ready to dive deep. Today, we're cracking the code of what makes a truly great software engineer.
Oh, yeah, and we've got a pretty incredible roadmap for this deep dive.
That's right. We're going behind the scenes with some real experts.
Straight from Microsoft.
Yeah, Microsoft researchers,
They
actually.
interviewed 59 experienced engineers across 13 different divisions.
And they found 53 specific attributes that set these top performers apart.
53.
53. And spoiler alert, it's not just about coding skills.
You're telling me. Get ready for some surprises because we're going to be talking about things like being passionate and data-driven.
Yeah, even things like creating a safe haven. So if you're ready to level up your understanding of what it takes to really excel in this field,
Buckle up.
this is the deep dive for you.
Okay, let's start with the foundation, technical expertise.
Yeah, obviously you need to know how to code, but
That's just the beginning.
it's like,
You can't build a skyscraper on sand.
yeah, you need that solid concrete base.
Yeah. But the real magic is in the architecture, the design, how it all comes together.
So what are some of those architectural elements of a great software engineer? What makes them stand out beyond just knowing the syntax?
Well, for one, they're passionate. And not just about code, but about solving problems, learning new things, pushing the boundaries of what's possible. The researchers even use this analogy of running up an infinite escalator.
I love that. That's such a great way to describe the constant learning and evolution that's required in this field.
Right. Like you snooze, you lose.
Absolutely. And that ties into another key attribute, being data-driven.
Yes. These engineers don't rely on hunches or gut feelings. They're constantly measuring, analyzing, testing their assumptions against hard data.
So it's about being smart, but in a systematic way, using data to guide your decisions. Can you give me an example of what that looks like in practice?
Sure. Imagine you're designing a new feature.
Okay.
A data-driven engineer wouldn't just jump into coding. They'd analyze user behavior, research existing solutions, A/B test different designs.
Yeah. To really optimize everything.
Exactly. Optimize for user engagement, performance, accessibility. You know they're using data at every step to make informed choices.
That's a great example. And it makes me think about another thing that the researchers highlighted, decision making. Because it's not just about writing code, it's about navigating complex situations and making those critical calls. So what did they have to say about that?
Well, one of the key findings is that great engineers, they have an incredible grasp of context.
Context.
Yeah, they're not just thinking about the technical details. They're considering the bigger picture, like the customers, the business needs, the tools they're using, even the dynamics of the people involved.
So they're like master chess players, thinking several moves ahead, anticipating the ripple effects of every decision.
Exactly. And they shared this really interesting anecdote about a senior engineer who was leading a complex project. And he wasn't just focused on the technical deliverables. He was really obsessed with making sure his entire team had the right training and understanding of the project goals. He was demanding code reviews, not just to catch bugs, but to help his team learn and grow.
Wow. Talk about leadership. It's not just about writing elegant code yourself. It's about empowering your entire team to excel. I think that's something we can all learn from whether we're leading a team or just working on our own projects.
Absolutely. And speaking of teams, that brings us to another major theme, communication.
Okay.
And not just any kind of communication. They specifically highlighted this concept of creating shared context.
Shared context. What does that actually mean in the world of software engineering?
Well, it's about making sure everyone involved in a project, from your fellow engineers to product managers, designers, even executives, are all on the same page. You're proactively communicating your design decisions, clarifying assumptions, anticipating potential misunderstandings before they derail the project.
So you're like building a bridge between the technical world and the rest of the business.
Exactly.
As I can see how that would be so important, especially with a complex project where there are so many moving parts.
Right. And it takes more than just technical knowledge. You need empathy, you need the ability to see things from different perspectives and tailor your communication to your audience. They even mentioned the importance of translating complex technical concepts into language that non-technical stakeholders can understand.
So think about your last project. Were you effectively creating that shared context? Did you clearly communicate your design decisions and your rationale, the potential trade-offs? If not, how could you improve your communication based on what we're talking about?
It's definitely worth reflecting on.
Okay. Let's shift gears a bit and talk about the software itself. What does the code produced by these great engineers actually look like?
Well, the researchers use one word to describe it: elegant.
Elegant code. I've heard of elegant design, elegant fashion, but elegant code. That sounds almost poetic.
It is, in a way.
Okay.
They defined it as software that's simple, intuitive, easy to understand, even for someone who didn't write it.
Yeah,
And they even said doing something well and in a very simple way is very, very hard.
that's so true. I'm thinking about some of the apps that I use every day, the ones that just work seamlessly, intuitively, and I never have to think about the complexity behind them because they're so well designed, so elegant.
Exactly. And elegance isn't just about aesthetics. It's about creating software that's efficient, maintainable, and frankly, just a joy to work with.
So it's not just about writing code that works, it's about writing code that's beautiful, in a sense, code that other engineers can look up to admire and learn from.
Precisely. And this attention to detail, this pursuit of elegance, it's not just about aesthetics. It's about building software that can stand the test of time. And that brings us to another really fascinating attribute, anticipating future needs.
Yeah, the crystal ball of software engineering.
Yeah.
How do these top performers manage to build software that can actually handle the challenges of tomorrow?
Well, they told this story about QQ.
QQ.
It's a Chinese chat program.
Oh, okay.
It was designed 15 years ago to handle a few million users. But today it has hundreds of millions, and it still works seamlessly.
Wow.
That's the power of foresight.
So they're thinking ahead, planning for scalability.
Exactly. But of course, there's a danger in over-engineering, building in too much flexibility for scenarios that might never actually arise.
Right. It's like that delicate balance. You have to be forward-thinking, but also pragmatic, making strategic decisions based on the best information available. And sometimes that means saying no to features or flexibility that seem tempting, but might not be worth the cost.
Exactly. It's a tightrope walk.
Welcome back to our deep dive into the minds of great software engineers. We left off talking about that balancing act of anticipating future needs without going overboard.
Yeah. It's all about being a master of trade-offs. Weighing those potential benefits against the costs and complexity.
So making strategic decisions based on the context.
Exactly. And to do that well, you need something else that these engineers have in abundance. A meticulous attention to detail.
Ah, yes, the devil is in the details. But what does that look like in the world of software? Does it mean spending hours, obsessing over code formatting?
Well, it's more than just aesthetics. Although clean and readable code is certainly important.
Right.
These engineers, they have this almost microscopic vision for potential issues. They sweat the small stuff because they understand that seemingly insignificant things can have a huge impact down the line.
So give me a concrete example. What does this attention to detail look like in practice?
Okay, imagine you're writing a function to process user input. A great engineer wouldn't just assume that the input will always be valid. They'd carefully validate every single piece of data, handle edge cases, sanitize inputs to prevent security vulnerabilities, write unit tests to ensure that that function behaves as expected under all conditions.
So it's about anticipating those potential problems before they even arise.
Right. Building in safeguards, making sure the code is robust and resilient.
Okay.
Actually, the researchers quoted one of the engineers saying, the quality of the code, performance, space, and how many bugs it has, how robust it is, and how it handles exceptions will have great differences.
It's like they're building software with the same meticulous care and precision as a master craftsman building a fine watch or something.
That's a great analogy. And speaking of craftsmanship, the researchers also talked about this concept of creating software that is fitted.
Fitted, like a tailored suit. What does that even mean when we're talking about software?
Well, it means that great engineers think about how their code will fit into the larger ecosystem. They're not just building isolated components. They're thinking about how their work will interact with other parts of the system, with the users, even the existing infrastructure.
Oh, understanding the interconnectedness of everything.
Yeah, and making sure that your code plays well with others.
Right.
One engineer actually said, you need to understand better interactions around you or around your code, how your code is supposed to work. If I tweaked this here, I'm not going to break something else. So it's like having that systems level thinking, seeing the forest for the trees.
I was going to say it's like one of those intricate domino chain reactions. You have to be incredibly careful and precise to make sure that everything falls into place as intended.
Yeah, exactly. And to maintain that precision and control, especially in complex projects, you need a solid process.
Okay.
The researchers talked about evolving software, which emphasizes the importance of iterative development and incremental delivery.
So you're not trying to build the entire system in one go. You're breaking it down into manageable chunks, building and testing those pieces, and gradually assembling the final product.
Exactly. One of the engineers actually described it as a very clean, stepwise process moving forward. How can we break this down so that we have really concrete deliverables on an ongoing basis? So it's about managing complexity, reducing risk, making sure that you're always moving in the right direction.
And I imagine this approach would be especially valuable in, agile environments where requirements can change quickly. You need that flexibility to adapt and adjust your course as you go.
Absolutely. And this ties into another crucial attribute, long-term thinking. These great engineers, they're not just focused on the immediate task at hand,
Yeah.
they're thinking about the long-term implications of every decision.
So they're playing chess, they're thinking several moves ahead, anticipating their opponent's